Hi, my name is Sophia I'm a junior at the Episcopal Academy in Newtown Square, Pennsylvania, and my study this year for the IYRC 2022 is the correlation of social determinants of health, poverty, and political participation with COVID-19 vaccination rates. So my presentation will have 8 components today: the introduction, objectives, hypothesis, methodology, results, analysis, conclusion, and references. Vaccine hesitancy and vaccine resistance have long prolonged the COVID-19 pandemic, directly impacting many lives. This study aims to explore factors that limit COVID-19 vaccine uptake, particularly social determinants of health, race, ethnicity, political participation, and wealth. So by exploring the potential socioeconomic factors that correlate with being fully vaccinated, the goal of this project is to identify possible discrepancies between the trends of vaccination rates against the explored socioeconomic factors for one race versus the trends for another race. If a pattern is identified, it should help serve local or even regional governments as evidence that certain implemented policies are not representative of the whole state or regional population. Furthermore, identified correlations against socioeconomic factors can be used to determine what types of measures being taken to increase COVID-19 vaccination rates are useful and which that need to be reworked. So my hypothesis was that it is hypothesized that social determinants of health will have different impacts on COVID-19 vaccination rates and flu vaccination rates in different racial and ethnic populations. So in other words, I hypothesized that race itself is a factor that influences correlations between social determinants of health and vaccination rates, perhaps due to disparities in healthcare rooted in race. So I used 3 main databases: the CDC, the Center of Disease Control and Prevention, the Kaiser Family Foundation, also known as KFF, and RStudio for my statistical analysis. So the CDC, I got my COVID fully vaccinated data from, and also the glossary for defining races and ethnicities. The Kaiser Family Foundation defines races and ethnicities as the same as the CDC. And I got my flu vaccination rates from the Kaiser Family Foundation, as well as my social determinants of health. So the CDC defines, that being said, I'm going to define these 4 races throughout the CDC says. The CDC defines white as a person having origins in any of the original peoples of Europe, the Middle East, or North Africa; Black as a person having origins in any of the Black racial groups of Africa. Terms such as Haitian or can be used in addition to Black or African American. Hispanic as a person of Cuban, Mexican, Puerto Rican, Cuban, Central or South American, or any other Spanish cultural origin regardless of race. And finally, Asian as a person having origins in any of the original Far peoples of Far East, Southeast Asia, or the Indian subcontinent, including, for example, Cambodia, China, India, Japan, Korea, Malaysia, Pakistan, the Philippine Islands, Thailand, and Vietnam. So then I'm going to briefly go over my variables as well. So I had 12 variables. The first one, the asthma, was the percentage of whites, blacks, Hispanics, or Asians who have asthma on a state-by-state basis. DIA, the percentage of whites, blacks, Hispanics, or Asians who have diabetes on a state-by-state basis. Disability, the percentage of whites, blacks, Hispanics, or Asians who have a disability on a state-by-state basis. Physical is the percentage of whites, blacks, Hispanics, or Asians who reported doing a physical activity on a state-by-state basis. Poverty, the percentage of whites, blacks, Hispanics, or Asians living in poverty on a state-by-state basis. Health, the percentage of whites, blacks, Hispanics, or Asians who report a fair or poor health on a state-by-state basis. Next, 6, the percentage of whites, blacks, Hispanics, or Asians who have arthritis on a state-by-state basis. Obese, the percentage of whites, blacks, Hispanics, or Asians who are obese on a state-by-state basis. FV stands for fully vaccinated, which means the percentage of whites, blacks, Hispanics, or Asians who are fully COVID-19 vaccinated on a state-by-state basis. Dentist, the percentage of whites, blacks, Hispanics, or Asians who have gone to a dentist in the past year on a state-by-state basis. Flu was actually only the percentage of whites, blacks, or Hispanics. The Kaiser Family Foundation did not have data on the percentage of Asians who have gotten the flu vaccine on a state-by-state basis. And lastly, voted, the percentage of whites, blacks, Hispanics, or Asians who have voted in either the 2014, 2016, 2018, or 2020 elections on a state-by-state basis. So now I'm going to briefly describe my process of my methodology. So first, I had to clean the data in RStudio, which meant that I had to remove lots of NA values, and also there are many values that were greater than 99%, which RStudio cannot read because it is not an integer. So I interpreted greater than 99% as 1, being 100%. Next, I did scatter plots. So the first plot I did was COVID against flu, and then I did COVID versus the other socioeconomic factors, and then flu versus the same socioeconomic factors, to see if the trends for the 2 vaccines were similar or the same. Then I originally was going to use an R-squared value to validate my data results. However, I then used actually a p-values instead, which is a type of linear regression modeling, because p-values are better for determining whether the observed relationships also exist in a larger population, which is extremely useful in my study. Lastly, I did a decision tree, which is a type of machine learning, which I will be explaining more later on. So this is my data table. As you can see, these the data table is percentages from the probability from 0 to 1, and they're all rounded to either the hundredths or the thousandths. Then I had to do a normal QQ plot on the left or a homoscedality plot on the right, because these two plots help me confirm that I can use that these relationships are linear, so I can in fact use scatter plots or to validate my results. So the QQ plots, you can see there's a positive sloping trend line. So because my points are very close to this positive sloping trend line, that means that it passes the test. And then for homoscedality, my points are evenly spread on both sides of the horizontal line, which also passes the test, which means that this relationship is linear. If not, I would have to take the log of each of the data for each factor. So then, as like I mentioned before, the first scatter plot I did was COVID versus flu. As you can see here, that there is a positive correlation because the p-value is less than 0.05, which means it's significant. But there's no correlation for Black or Hispanic because the p-value is greater than 0.05. Then the first socioeconomic factor I did was physical activity versus COVID-19. As you can see, p-value is significant, and you can see a correlation bottom right on the chart on the scatter plots, but not really a correlation for the other three. Same thing, but against flu, again, positive correlation, as you can see on the top of the top scatter plot, and also a small p-value, but too big of a p-value for Black and Hispanics. Then I did COVID-19 vaccination rates versus obesity. Again, this time there's a negative correlation for whites. It's proven by the small p-value, but not really a correlation for the other three. Hispanic, you can sort of kind of see a correlation since it is less than 0.05, but the p-value for white is much more significant since it's much smaller. Then flu vaccination rates versus obesity, same thing, negative correlation for whites, no correlation for the other two. Then poor for health, versus COVID-19 vaccination rates. A negative correlation for whites, as proven by the small p-value in the table, and then same thing here, flu vaccination against fair or poor health, negative correlation for whites with a significant p-value. Then COVID-19 vaccination rates versus voting, a positive correlation with a significant p-value for whites, but not really any significant correlations with the other three races. Same thing, flu vaccination versus voting, positive correlation for the whites, and no correlation for the other two. Lastly, I did COVID-19 vaccination rates versus poverty, a negative correlation for whites, as you can see with a small p-value, and too big of p-values for the other three races. Then flu vaccination rates versus poverty, negative correlation with a significant p-value for whites, no correlation for Blacks or Hispanics. And then I did a decision tree. So decision tree is a type of machine learning that basically takes all the variables and picks out which ones are significant or not. And it basically this decision tree can predict the probability of a white population of any given state being the percentage of them being fully vaccinated for COVID-19. And the decision tree is very useful because not only does it predict the probability of something happening, but it also it doesn't require any cleaning of data, so it is very efficient and easy to use. So after putting in all the socioeconomic variables, my decision tree picked out that obesity, going to the dentist, having a disability, reporting fair or poor health, having arthritis, were the most significant variables. And it also spits out a miscalculation error, about 11.7% in this case, which is very low. And to test to see if my decision tree is accurate or not, I actually used the data from my own data table for my state, Pennsylvania, to test this. So basically how it works is, so for the first, at the very top, it's obese. So we take the data, which is 0.331 for Pennsylvania, and we plug it into the inequality given. Since the inequality is not met, we take the path to the right here. So then we have to do the same inequality, but for dentists. So we take the data for dentists, and we again see that the inequality is not met. So we take the path to the right again, which gives us a predicted probability of 70%. And the actual was actually 64%. So it's only 6% off, which is a great miscalculation error. So limitations of this research different demographic data from the U.S. Centers for Disease Control and Prevention, and the Kaiser Family Foundation might have used different methodologies. Another limitation is that each data set contains far more data points for the white population than for Black, Hispanic, and Asian populations, making it much more difficult to draw statistical conclusions for Black, Hispanic, and Asian communities. In our studio, many statistical tests were run, did not yield promising results due to limited degrees of freedom from the data. Additionally, one final limitation is that correlation does not necessarily imply causation. Confounding factors may be present that systematically affect the data. So if I were to redo the study or further study, I would possibly explore some of the policy changes that are needed, because as you can see here, it's possibly unrepresentative of the whole population, since there are only correlations for the white population. And then I would also add in another potential socioeconomic factor of education. So does education cause vaccine hesitancy? So in conclusion, this study explored correlations between socioeconomic factors, COVID-19 vaccination rates, and flu vaccination rates in white, Black, Hispanic, and Asian populations using state-by-state data. It was hypothesized that social determinants of health will have different impacts on COVID-19 vaccination rates and flu vaccination rates in different racial and ethnic populations. The hypothesis was supported by the results. Correlations between vaccination rates and socioeconomic factors such as underlying health status, poverty, and political participation were only significant in white populations. The results suggest that perhaps race itself is a factor, and there's an underlying issue that accounts for the disparities among Black, Hispanic, and Asian populations. Thus, in order to address vaccine hesitancy, underlying issues such as medical mistrust need to be identified and addressed. Additionally, further studies that analyze the differences between Blacks, Hispanics, and Asian populations, or explore the significance of education as a socioeconomic factor on vaccination rates, will be important to further increase vaccination rates around the world. And here are the references that I used. Thank you, and I will now take any questions. And I also would like to thank Dr. Bhatia for helping me through this process and helping and guide me to write this paper.